A polyphonic synthesizer has a number of preset internal synth voices that it uses to play many notes simultaneously. We've already seen that we call those channels when we're working with the MC devices in Macs. In a typical polyphonic synthesizer, all the MIDI notes that are held down on a keyboard are sent on a single MIDI channel, and then the synthesizer has to allocate MIDI notes to be played by specific synthesizer voices. So the allocation is saying the note C that's held down, that will be played back by oscillator 4, and the note F sharp that's held down, that'll be played by oscillator 6. That's the allocation of MIDI notes to internal synthesizer voices. And that was always the role of the synthesizer to allocate notes to voices. When we move to an MPE situation, voice allocation happens at the controller. Instead, we shift that burden, or that decision of which MIDI note is played back by which oscillator, we shift that over to the controller itself. So with an MPE controller, if I hold down 4 notes, they'll be sent on 4 different MIDI channels. The synthesizer has to recognize which channel each one of those notes is on and route the MIDI note message to the correct synthesizer voice that corresponds with that channel. Now this change of burden of voice allocation now happening on the controller instead of the synthesizer is not really a concern for most musicians, but as we program our own synth, it makes a big difference. MC can be used in a variety of ways. We can use multi-channel cables for a lot of different purposes. We could use it to create unison voices in a single voice, so we can have many oscillators playing simultaneously, slightly detuned. In this example, I want to use MC as a form of polyphony instead of using the polytilde object. So I can use MC note allocator to do just what we were talking about earlier, allocating MIDI notes to MC channels, which are our oscillator voices. Now the first thing the note allocator does is send a message out of its last port, which is the voice message. It's saying use channel 5 or use channel 2 or use channel 3. Now that is sent to the MC target objects all over the patch. So we'll see that everywhere that we're converting from message to signal, we need to tell that object, usually MC line, which channel it should be functioning on. And so that's the only addition here. Really, after that, all this patch is really the same. You'll see that an aftertouch message is divided by 128 to put it into a good range. Then it's packaged up with another number to define the smoothing of MC line tilde. The big difference is MC target is here, which is what says this change in value is going to happen on this specific channel. Now, everywhere we have MC line, we've also established how many channels it's going to send after it. So that says channels 15, and now this cable is 15 different MIDI channels, which is representing the 15 oscillators that I'm using in my patch.